Hi SREcon. Thanks for taking the time to check out my talk. Although this stream is pre-recorded, I'm here in the chat with you, so please share your ideas, ask questions, and give feedback, and I'll respond in real time, and hopefully everybody else can also participate. So this is how to play games to improve incident response for your teams. I'm Austin King, nice to meet you. I'm a recovering Amazonian. And in my history, I've caused a lot of outages. I've jumped in to help restore systems that were down. And I'm just really into exploring the topic of how can we play games to get better at these skills? How can we do intentional practice? Before you can get better at incident response, there's some prerequisites. Your team, your org, your company will need to adopt some kind of incident management framework. If you haven't done that yet, that's okay. There's some great resources out there. An example would be PagerDuty's response.pagerduty.com documentation and training material. It's all open source and free. It's a great resource. BlackRock Partners provides training in the Bay Area, and I'm putting together a lot of free resources on OpsDrill.com as well. Once you've adopted your framework and tailored it down to your company, you're going to need to train everyone on it so that everyone knows what the expectations are. And then the last piece of the puzzle is practicing these skills so that you'll be sharp and prepared and ready for anything. So what are the foundational factors of your team and how this relates to being prepared for incident response? So some of the lowest level aspects are psychological and SRE team culture aspects. I'm not going to go super deep in this because this is such an important topic in the last few years that there have been many talks in previous SREcon that you can look up for any of these topics. But we really need to make sure that our teams have psychological safety, that we can take risks, be vulnerable, that we have a blameless culture, and that we have a growth culture. Next, we need to make sure that we have team cohesion, that we get timely feedback, that we have a shared sense of responsibility and a shared goal that we're all working towards. And lastly, we care about system resilience, but we also care about team resilience and getting rid of any single points of failure. So these are foundational elements that are really required before we can look at more incident response specific skills. So what are those core skills? I think that there's a set of skills and knowledge that your team, your org, and your company needs to get better at incident response. So let's talk about the core skills. The first two, curiosity and problem solving, are critical for incident responders. So those are, most of the people on a call are incident responders. They might be subject matter experts who are going to troubleshoot and try and identify exactly what the problem is and how we could mitigate it. So curiosity is really important, and I've been on some low curiosity teams coaching them, and an example of low curiosity is there's a software outage, and then the first idea someone has is that, oh, this is a networking problem, and so the incident commander gets networking involved, and the original team just kind of sits around and waits for networking. Networking looks at it and says, this is not a networking problem, and they prove why. And then and only then does that team start looking at their own software stack and coming up with ideas. So this is a lack of curiosity. We really want to be coming up with a hypothesis, testing them, and if we have any downtime, working on the next set of hypothesis. What else could it be? Assuming this thing is not it, what else could it be? What else could it be? So those two skills are coachable. We're going to talk about some games to improve that. And then the next three skills, communication, delegation, and coordination, are critical for an incident commander or a call leader, somebody who is not the incident responder and is keeping track of time, who has what tasks, and moving the call forward. The great thing about all these skills is that they're highly portable. Regardless of if you switch teams, orgs, companies, really, even if you switched into a completely different type of work, all of these skills are portable to those contexts and will be really helpful for the rest of your life, inside of work and outside of work. What's much less portable is the knowledge we need. So if you're an Azure shop and your team owns the database, you might need to know Cosmos DB inside and out. You might need to know what can fail, what are the resource limitations, how does replication work? And comparing that to, say, a Kubernetes shop or an AWS shop, the knowledge that you need to have may be completely different. So why does this matter? Why does being great at incident response matter? One metric we can use to measure how well we're doing is MTTR, mean time to restore. And the R is often a different word than restore, depending on the org or the team. You have recovery, resolution, remediation, etc. But ultimately, your software is down for a certain amount of time before you can do a Band-Aid fix to stop the bleeding for your customers and bring things back up. And if you measure that time for every outage, say in the past year, and then took the average of that, that's the mean time to recovery. And this is something that we can lower as we get better at incident response. So we talked a lot about psychological factors and team coherence factors. Some anti-patterns that can happen during incidents that really slow things down are, for example, the bystander effect, where everybody kind of assumes that somebody else is going to jump in and help out. There's not this shared responsibility. Another one is if your team spends the first 5 or 10 minutes of an incident arguing about who's to blame, who committed code at 4 p.m. on a Friday and closed their laptop and disabled notifications on their phone. If our team has out-of-date runbooks or missing runbooks, that can really help hurt our ability as an incident responder at being more efficient and fast at figuring out what's going on and remediating the problem. It's really important to understand that when our software is down, we're hemorrhaging money. If you don't know how costly it is to your company when your particular service is down for 5 minutes, it's a great exercise to do some napkin math and make a ballpark estimate. And it can really help motivate your team during an incident. If you're an incident commander, you can remind the team of how much money is being lost every 5 minutes. Also, ultimately, we all want to help our customers. And when they go to use our software and it's degraded or even completely down, they lose trust in our brand, and that doesn't feel good. So how can we grow at SRE Culture? I want to suggest games as a great way to do that. And I kind of want to stretch the definition of games to drills and some different operational drills that we'll look at. So how do we go about this intentional practice in playing games? If we look outside of our industry, say a soccer team, soccer teams don't just play soccer games. They don't just scrimmage all the time. Soccer coaches will design and adopt a series of drills to test very specific skills. For penalty kicks, for example, come up during games again and again. So they may set a penalty kicker up and have the rest of the team in positions that are to block the ball. And the player can practice that one skill intentionally of kicking a penalty goal. They may kick five goals and then rotate through every player on the team. So they can get really quick feedback from the coach on exactly that task that they're doing. Similarly, if we look at the fire department, firefighters have an incredibly dangerous job, and they do drills to maintain their skills and practice. An example would be intentionally setting a structure on fire and then practice carefully entering and safely exiting a structure that's on fire. So this can really build up the muscle memory of those skills and reduce panic and chaos when there's an actual real fire. And this is so important because not only are firefighters' lives in danger, but the people they're trying to help and rescue as well. And then more close to our industry is InfoSec, cybersecurity, kind of security in general. I think security is way ahead of us on using games and drills to get better. And one example would be Capture the Flag, which is incredibly popular in this community. There's two ways to play Capture the Flag, but I'll just tell you about one particular way. Two teams, a red team and a blue team, will each have software installations that they need to operate. And each of these will have a vulnerability put into it. The team doesn't know what that vulnerability is. And so a team has to decide how much time to invest in hardening their system so that it can't be attacked, and how much time they should spend attacking the other team's system. The first team to exploit the vulnerability in the other team's code and kind of captures the flag, and they can kind of prove that they figured it out. Really, really cool game. There's one going on almost every week that you can participate in if you're curious. So I've been looking at different games and talking to different teams about what they're doing, and I've tried to organize this kind of inspired by Maslow's hierarchy of needs. This pyramid, each layer is a dependency that the other layers build upon. So at the lowest layer, there's trust, bonding, and safety. You know, we talk about team building and we kind of make fun of trust falls, but there is a purpose to this ultimately. This is kind of the social foundation. And although we don't want to use trust falls, maybe there's some games that can help us build that. Next is communication. So if we can find games that stress calm, clear speech, that could be really helpful. A building on communication is delegation. So if we could find some role-based games that provide opportunities for leadership, that would be really great. And then building on top of all these are incident response skills and just the core competencies that we need to be great at it. So I found categories of games that we can play to exercise and practice. For trust, bonding, and safety, we're going to look at party games. These are casual games. I think everybody watching the stream has played some kind of party game in the past with your family or your coworkers, and we'll look at an example. For communication, we have asymmetrical co-op games. That's a mouthful of fancy words, so let's break that down. Asymmetrical simply means that there are at least two parties and that they have some different information between the two. We'll look at a specific game to get a better idea of how this works. And then co-op is really just a fancy word. It's short for cooperative and just a fancy word for all the games that we're going to talk about. Party games are cooperative too. They're just typically not labeled as co-op. And delegation, we'll look at some role-based co-op games. And then lastly, for skills, I don't have a great name for this bucket, so I'm just going to call them OpsDrills, and we'll look at several. So in terms of party games, a great example of one that can be played in person or remotely online is Jackbox. This is very popular. You can purchase it through the Steam video game marketplace, and it's a collection of mini games. An example of one would be Drawful, where one player on your team gets a word, and then they need to try and draw with stick figures or by any means to get everyone to guess, and the first person that guesses correctly gets some points. So this allows us a space to be vulnerable, to be playful, to laugh at ourselves, and to just an icebreaker, understand other people's preferences, get to know each other. So there's lots and lots, there's thousands and thousands of party games, and any of them could be good for kind of building the social trust layer. Next up, for communication, And an example of an asymmetrical co-op game is keep talking and nobody explodes. So the way this game works is that there's a bomb, and this could be physically in person, but more likely virtually remote. You can play this game that way. There's a bomb that is reconfigurable every time you play it. It may have multiple dials, multiple buttons, multiple wires, the number of batteries, the orientation of the wires, horizontal or vertical, etc. And so one player is the bomb diffuser. They're the only people that can actually see the bomb and its configuration. And they need to clearly and calmly describe the bomb to the rest of the team. And they are playing the role of the experts. So they have a bomb diffusion manual, and it's a collection of kind of logical statements. If there's a yellow wire above a red wire above a blue wire, and there are no other wires, cut the yellow wire. Lastly, this bomb has a countdown timer. So if it reaches 0 before the team diffuses the bomb blows up. If the bomb diffuser cuts the wrong wire or tries the wrong operation, the bomb blows up. So the bomb diffuser and the experts need to communicate well so that they can find the appropriate rule in the rule book and cut the right wire and save the day. Next up, for role-based co-op games, we have Overcooked. I love this example because from my understanding of the word chef, it's a French derivation of chef de cuisine, and that my understanding of the translation is that it's roughly boss of the kitchen or leader of the kitchen. So the way that Overcooked works is that there's a kitchen with multiple stations. There's a dishwashing station, a vegetable chopping station, a grilling station, and then a window to deliver food to customers. And although no one is forced to take any role, just because of space and walking from one space to another, people tend to specialize at one station. And there's limited resources. There's a limited amount of time, and there's a limited amount of clean plates, and items can only cook for so long before they're burnt. So early on, a chaotic team will do fine, but as these resources get constrained, it really helps if someone steps up and takes leadership. Because it turns out, just like in real life, nobody in Overcooked wants to clean dirty dishes. So if Jane takes the leadership role and says, hey Bob, could you go wash 5 dishes before returning to the vegetable chopping station? Do you acknowledge that? That can be really helpful, and Jane can look at what's the next resource constraint that's coming and kind of plan ahead and delegate. So really, really fun game for practicing delegation. The last bucket, OpsDrills, I'm going to share 4 examples. These are ways to give us more domain-specific, more closer to incident response type of drills and games that we can play. And I'm going to share some in order of how easy it is to adopt, so that the first ones you could adopt today, right now, and then by the end of the list, you might have to have a roadmap, and it might take a while to get there to adopt it. So the first thing is tabletop exercises. So tabletop exercises are very popular in cybersecurity, but also the military and the government. An example would be FEMA. They are responsible for responding to natural disasters, and they might use tabletop sessions to do kind of dry runs and test their plans just verbally. For example, if they said, what would happen if we had a hurricane on top of already ongoing power grid failure, and see how their preparations do in those scenarios. So all you need in terms of equipment is you need a scenario that you're going to practice, and it can be helpful to just have someone who's more senior or somebody who just wants to look through your past incidents to kind of brainstorm up a scenario with a lot of detail. Then you need a meeting. Could be 1 hour, 2 hours. 6 hours if you want to go that far down the rabbit hole. And you'll just need a Zoom call or something like that. And then the person or persons who creates the scenario, they need to document that scenario for everyone. That could be in a wiki, a PowerPoint, something like that. So they'll explain the scenario, and tabletopping is kind of like Dungeons and Dragons with a game master or dungeon master. So this person is going to help facilitate and move the story along as people can talk about what they would do when they're faced with this scenario. What runbooks would they use? What observability tools would they check, etc. So tabletopping can be really helpful for finding missing runbooks, missing automations, missing guardrails that you need to put in place. One note is who do you invite to tabletopping? You could do it within just your team, or you could do it kind of across your org. And I'm going to share a couple surprising roles that I would suggest might be useful to invite. Executives, legal, and marketing. So executives who are outside of engineering and don't have a good rapport with engineering can be a great stakeholder to invite. During a real outage, a real incident, an executive might feel completely out of control because they're used to having a lot of control and power, and then now the site's down and they have to rely on engineering to bring the site back up. If they don't have much of a rapport, they might join the call and try and take over control or ask the team to do certain things, which ultimately is just slowing everything down and causing confusion. By inviting them to a tabletopping session in a safe environment, they can kind of observe the skill and the knowledge and the preparation that engineering has, the systematic way we work towards restoring systems. They also may see what operational preparation you've done and which things you haven't been able to do due to prioritization. So if you're in a company that's always prioritizing features over some operations work and guardrails and automation, this can be really eye-opening and build that empathy between an executive and engineering. Similarly, by inviting a marketing person or a legal person, they just bring a diversity of opinion, and that is always a great thing. We want to have more ideas, more suggested solutions, and it might help them think about what promises we are making to our customers and whether or not those promises really needed to be made, or does everything kind of add up? It might give them ideas for projects that they need to spin up. So if a scenario was, we've lost the last 3 months of customer data and we went to restore from backup and the backups were bad and didn't work, and we really did lose 3 months of customer data. Having legal and marketing in the room could really stimulate some interesting conversations and potentially spin up some non-engineering projects over on their side of the house. Slightly more realistic than a tabletop exercise is a fire drill. And I want to talk about 2 ways to do fire drills. Again, the terminology is kind of loose. If you know of better terminology for these, please share it in the chat, and I'd love to hear your ideas. So the first type of fire drill is to pick one of your runbooks, maybe one that people are less familiar with, and page the current on-call. So you could cut them a ticket pointing to that runbook and ask them to execute every step in that runbook and to put notes and output and screenshots into the ticket. This might sound like it's not that useful, but actually it does a few things. It keeps the muscle memory and top of mindness of that runbook for that particular on-call. You can find out-of-date steps, so maybe a related system changed and we forgot to update this runbook. And it just helps keep the on-call sharp and prepared. A different type of fire drill would be to intentionally break maybe one node in your overall system in production, or if that's a bit too risky, maybe in staging. But to break something small and then have the on-call treat that as a real incident, and to page in other folks for help, and to practice your incident response framework as though it was a higher severity issue than it really is. If you're doing this in staging, it might be challenging. You may not have observability hooked up, or all of it. You might be missing dashboards. You might not have PagerDuty automatically integrated, or whatever tools you're using. And so that it might be less useful, or you might need to do a lot of work towards building staging out to be more like production. Ultimately, this is work you'd want to do anyways, but this is what makes adopting this a little bit harder than tabletop exercises. And this kind of manually breaking something naturally leads to chaos testing. There are a lot of great talks on chaos testing, so I won't go too deep, but the general idea of chaos testing, and Netflix is often given credit as one of the early leaders, is to have a hypothesis about your system. If I kill this one node, then the system will be resilient and self-heal. To do that experiment and to define some safe metrics that you'll abort the experiment under, and then to just do that test and make sure that the system self-heals and everything works the way that you expected it to. And an alternative way is to use the tools of chaos testing, but for a more novel situation that isn't part of necessarily your chaos testing program. There's a lot of great chaos testing tools out there. One company that is very helpful with lots of free training material is Gremlin, although there's other companies and lots of open source material, open source projects to help you accomplish this. So you can just repurpose those tools to break something in production or staging or development. And it's not necessarily that you're putting that into CI/CD and kind of running it all the time. Generally, chaos testing happens very frequently, which leads us to a related concept that happens much less frequently. So game days, my first experience with a game day, the first time I joined Amazon was in 2008. And after being an employee for 2 months, I was put on the on-call rotation. So I came in on a Monday morning, and at 10:30 I got paged by 5 or 6 different systems, and I just panicked and froze. I was like, I didn't know what to do. Luckily, my mentor was sitting next to me. He took the keyboard and kind of stepped me through incident response and how to investigate and how to restore the systems. But our org actually had no heads up about this game day. What the company decided to do was cut the power on an entire building, a data center, and to test that everybody was not having single points of failure. So typically with game days, there'll be a lot of planning, and you will let teams know what's going to happen. So another game day that I participated in that was more with some heads up was for Prime Day. So Prime Day is an artificial holiday to get us to spend more money. And the stressful thing about Prime Day is a lot of novel code is put up that only runs during a couple days a year during the Prime Day. These code paths are unique catalog experiences, different user flows, and also the traffic patterns are quite different. If something like a Nintendo Switch is featured, it's going to drive a ton of traffic to that part of the experience and that unique detail page. So just lots of challenges there with novel code that hasn't really been burned in and run in production before. So the way that game days are helpful is for testing those new code paths. And also, typically a team will have 1 or 6 or 7 feature flags for Prime Day. so that if a particular part of the code can't handle the load, you could fail back to some more traditional fallback experience, maybe hopefully code that has been running year round. And if you have 50 teams touching code that is going to be used during Prime Day, the permutations of every team having 6 or 7 feature flags and how those all interact can be quite a lot of testing. And back then at this time, they couldn't be exercised through end-to-end automated tests because there was no way to cause those feature flags to be tripped, and teams probably didn't even know about each other's particular feature flags. So that could be worked around technically, but at this time it wasn't possible. So by having a game day, artificial load was placed on these paths, and the teams could toggle their different feature flags on and off and find bugs if Team A's feature flag was turned off and Team B's feature flag was turned off, finding bugs with those cases. So super helpful. Game days are probably the hardest to get adoption. Chaos testing and game days, you really need executive buy-in. The company needs to be comfortable with production traffic and potentially some customers experiencing some issues as you're testing things in production. It requires the most code and software changes and infrastructure, but also can have really big rewards for making our systems resilient and allowing our teams to have more realistic practice for incident response. So I wanted to just thank you for the opportunity to speak today. And I am available in the chat. I'm enjoying the rest of the conference with you. But if you want to contact me down the road, I'm OpsDrill on Twitter. And I just really enjoy talking about games and incident response. Please send me an email, austin@opsdrill.com. Thank you so much.